Thank you, everyone, for joining us at Griffith Observatory for a live broadcast of the northernmost moon, which is helping us put a bow on Griffith Observatory's 90th year. Tonight, the moon is going to rise as far to the north as it ever does, and we won't see it do this again until about 18 years from now. It's the end of the major lunar standstill, a period of about 2 years in which the moon rises and sets as far to the north and to the south as we ever see it. And it's been doing this since late 2023, but tonight the show is over for another 18.61 years. I'm Dr. Ed Krupp, director of Griffith Observatory, and this cheering and unusual astronomical event closes our 2024-2025 campaign to follow the greatest monthly excursions of the moon. It is brought to you by Griffith Observatory, Griffith Observatory Foundation, and the City of Los Angeles Department of Recreation and Parks, and, of course, the law of gravity, which is responsible for the moon's behavior. The sun set earlier tonight at 4:43 p.m. Pacific Standard Time. Observatory cameras are now targeting this view of the northeast horizon from a point on the far west side of the observatory's front lawn. In a short time from now, the moon will rise on this line of sight we've installed, and we'll catch it just about as far to the north as we ever see it. The full moon will appear over the distant mountain ridge at about 5:48 p.m. Pacific Standard Time, and the Griffith Observatory live stream broadcast team is prepared to catch that moonlight. The broadcast team includes Griffith Observatory Theater's manager Patrick So, production engineer Matthew Berlando, Observatory Astronomical Observer Vanessa Alarcon, video production coordinator Ella Ritz, Observatory Carpenter Grant Armstrong, Observatory Electrician James Vega, Digital Communications Coordinator Pixie Awada, and Stage Manager Michael Noble. Now, we first broadcast the southernmost moonrise in June and July last year. And since then, we've also transmitted the southernmost moonset, and here the northernmost moonrise, and the southernmost transit of the moon live to the world from Griffith Observatory, and also the northernmost moonrise from the vicinity of the ancestral Pueblo Great House at Chimney Rock National Monument in southwest Colorado. The moon hasn't been rising and setting this far north since 2006. Its orbit is now tilted at its greatest angle outside the path of the sun. And those white disks you see on that sphere that represents the sky represent the moon on its path. The other circle is the sun's path. On the ground, this means over the last 2 years, we've seen the most northern and southern moonrises and moonsets the moon ever reaches. Here again is our major standstill moonwatch view. The northernmost moon will appear on the line of lights that extends across the lawns. The greatest excursions of the moonset are marked with lines on Griffith Observatory's lower west terrace, along with lines for the solstice and equinox sunsets, and for moonsets when the monthly excursion is least, at minor standstill. The observatory was still under construction for renovation and expansion at the last major standstill in 2006. The stone for the line had not yet been placed in the pavement, and this is, in fact, the major standstill northern moonset on January 28, 2006. Although we call this period the major lunar standstill, the moon doesn't really stand still. Its monthly excursions just reach roughly the same maximum limits each month for about 2 years, the limits we see in the diagram. The sun does something similar, but it does it over the course of a year. In this illustration of the sunrise limits on the eastern horizon, the June sun is rising on the left as far north as we ever see it. And 6 months later, in December, it rises at its southernmost limit, which is over there on the right. To the unaided eye, the position of sunrise and sunset at these times of year does not seem to change for about 3 days. The sunrise and sunset seem to stand still. And the time when this happens is called a solstice, which means sun still. Well, the Griffith Observatory cameras are still targeting the northeast horizon, where the northernmost moon will soon rise. If we think of the sky as a hemispherical screen, like a planetarium dome, we can imagine how the sun, moon, planets, and stars all rise somewhere from the eastern half of the horizon, on the near side in this view, and from there they climb up the sky to their greatest height and then head back down to the western horizon on the far side of the dome. Celestial objects all rise and set like this because the Earth is spinning on its axis, and that makes the sky seem to turn around the North Celestial Pole, a spot directly above the Earth's North Pole. Now, if that were all that moves, the sky would be simple. But other objects, like the sun, moon, and planets, also all move around the sky on their own paths at different rates. Here we imagine the sky as a sphere, with the Earth at the center, and we can see half of the sky overhead, but the other half is hidden by the Earth beneath our feet. The sun's path through the entire sky is marked there. It's called the ecliptic, and it's just a reflection of the Earth's orbital motion around the sun. The sun takes about 365 days a year to complete its circuit, and the tilt of the sun's path shifts the sunrise and sunset from north to south and back to north again in a year. Each month, the moon circles the Earth in 27 days. That's its orbit shown in that same kind of diagram. The tilt of the moon's orbit guarantees the moonrise will migrate from north to south and back to north again in that time. So the moon does, in about a month, what the sun does in a year. It moves from north to south and back again, but the moon does something else. The moon's monthly limits gradually change, and over 18.61 years, the moon's limits move from outside the sun's limits to inside the sun's limits, and then back outside the sun's limits again. The moonset lines on the lower west terrace of Griffith Observatory make this obvious. The gray lines for the northern moon's inner and outer limits flank the gold summer solstice sunset line that points to the northwest. And the gray lines for the moon's southern inner and outer limits flank the gold winter solstice sunset line that points to the southwest. When the moonrises and moonsets reach these points, the limits don't seem to change much from month to month. And so these periods are the standstills, one at the moon's inner limits and another at the moon's outer limits. The moon's limits still change through these periods, but the change from month to month is small, just as the daily change of the sun's position at the solstices is small. And that's why we call the moon's limits the lunar standstills. Well, we are now at the end of the major standstill, the time when the moon's monthly limits are far outside the sun's annual limits. The extreme moonrises and moonsets are farther north and farther south than the solstice sunrises and solstice sunsets. Another 9.3 years, the limits for the moonrises and moonsets will be inside those points and will be at minor standstill. And the monthly limits will then gradually increase again. And in 2042, we'll have the next major standstill. So mark it on your calendar. Now, the moon behaves this way for two reasons. First, the moon's orbit is tilted a bit compared to the Earth's orbit around the sun, and we can see that tilt here. Second, thanks to the gravitational pull of the sun, the moon's orbit swivels. That changes the angle of lunar excursion and the amount of the moon's reach. This Fisk planetarium animation shows how the rotation of the moon's orbit changes the angle at which we see it. These edge-on views of the Earth, the sun, and the moon show how the moon's orbit flips from a greater angle to a smaller angle and back again with respect to the sun. And although the varying limits of moonrise and moonset are noticeable over time, most people, including professional astronomers, have no experience with this aspect of the moon. You have to track the moon systematically, month after month, for several years to realize the moon is doing this. And you would have to track it for several 18.61-year cycles to see and understand the full pattern. And that's what we're doing at Griffith Observatory tonight. Okay, we're still several steps ahead of the major standstill northern moon, which will show up soon. Despite the difficulty in mastering lunar standstills, some investigations of archaeological monuments, particularly Stonehenge, you see here, have led some investigators to propose that lunar standstill alignments were designed into some ancient and prehistoric sites. In the 1960s, C.A. Newham and astronomer Gerald S. Hawkins independently identified lunar standstill alignments in the so-called Station Stones rectangle at Stonehenge. The rectangle enclosed the main circle of stones and was constructed earlier, perhaps 4,500 years ago. The long sides of the rectangle coincide with the directions Major Standstill Southern Moonrise and Major Standstill Northern Moon Set. So here, in fact, is the view to Major Standstill Southern Moonrise, and here is the Stonehenge Station's view to Major Standstill Northern Moon Set. Dr. Clive Ruggles, Dr. Amanda Chadburn, and Dr. Fabio Silva have been tracking the current major standstill at Stonehenge, and this is an image from one of their videos showing that moonrise. Gerald Hawkins also proposed sight lines between certain gaps in pairs of the archways formed by the large sarsen stones erected perhaps 500 years later. This pair of the openings accommodates the major standstill northern moon set. Now, Stonehenge was not the first prehistoric monument assigned a major lunar standstill alignment. That was Callanish, seen here. In 1908, British naval officer Boyle Somerville published a major standstill northern moonrise line for the Callanish stones in Scotland's Outer Hebrides. But then, in the 1980s, Gerald and Margaret Ponting instead favored this alignment to the transit of the low southern moon. Here, that transiting moon hugs the horizon in June 1987. The late Aubrey Burrell was the leading expert on prehistoric stone rings, and he identified major standstill southern alignments in the recumbent stone rings in the northeast of Scotland. The big recumbent stone, the stone that's lying on its side, on the moon's line, operates like a stage across which the southern moon dances, and this is the view to the southwest from the center of that same ring, the Castle Fraser stone circle. Jack Eddy, an American solar astronomer, spotlighted a 2,000-year-old major standstill northern moonrise alignment with the axis of the prehistoric Hopewell Circle and Octagon mounds at Newark, Ohio. You're looking along that axis there. And Stephen Patricia reconstructs here Newark's major standstill northern moonrise. The ancestral Pueblo Great House, about 1,000 years old, at Chimney Rock National Monument near Pagosa Springs, Colorado, accompanies the restricted view of the major standstill northern moonrise framed by the distinctive rock pillars. Some believe the Great House was built on this demanding mountain ridge to accommodate the northernmost moon in the Chimney Rock Gap. Griffith Observatory astronomical observer Vanessa Alarcon photographed the northernmost moon in October of 2023, and Dr. Amanda Bosch of Lowell Observatory caught the December 2023 full moon at Chimney Rock here. The Griffith Observatory remote live stream internet broadcast team captured and transmitted worldwide the major standstill northern moonrise at Chimney Rock this past September, and also in September and October of 2024. And those broadcasts are available on the Griffith Observatory website. A deliberate inclusion of lunar alignments in ancient and prehistoric monuments has not been proved and remains questionable. Griffith Observatory, on the other hand, possesses intentional lunar alignments, and Griffith Observatory is wrapping up the major standstill with tonight's moonrise. We are now about to witness in real time the major standstill northern moonrise from the far west side of the observatory's front lawns, along a moonrise line installed across the lawns and headed northeast over the San Gabriels, and it runs to the west of Mount Wilson and just east of Occidental Peak. As Frank Sinatra told us, the moon belongs to everyone The best things in life are free. The moon may be standing still, but Griffith Observatory never stops moving. Thank you for joining this Griffith Observatory broadcast of the December 5th, 2025 Major Standstill Northern Moonrise, the last northernmost moon for 18 years. And here on the lawn of Griffith Observatory, the crowd went silent for the whole time the moon was coming up, and as you online were hearing music accompanying it. This broadcast has been brought to you tonight by Griffith Observatory, Griffith Observatory Foundation, and the City of Los Angeles Department of Recreation and Parks. Please join us on Thursday evening, December 18, 2025, for Griffith Observatory's monthly program, All Space Considered, about, of course, all space. Dixie.
Microphone is hot.
Everybody ready?
So hot.
Good night, Moon.
Good night, Moon.
Good night, Moon. Good night, Moon.